Hi guys, in this video we will be solving one of the problems given in one of the Philippine Mathematical Olympiad competitions. And the problem is, if n is a positive integer, what is the smallest value of n such that quantity n plus 20 plus quantity n plus 21 plus quantity n plus 22 plus so on and so forth plus quantity n plus 100 is a perfect square? So let's check it out. Now, in order to solve the problem, notice that the expressions inside the parentheses are being added together. Now, each of the expressions in the parentheses contains the variable n. So, the problem is asking us basically to find for the value of n such that the sum of all these expressions added together will give us a perfect square. So for us to be able to find the solution, we need to add all the expressions because the expression has the addition symbol now. But notice that we have these three dots here, which indicates that we have a certain type of series formed in the expression. Now remember, there are two types of series, the arithmetic series and the geometric series. The geometric series, if two pairs of consecutive terms have the same ratio, and arithmetic series if two pairs of consecutive terms have the common difference. Now, before we can add them, we can add all of these expressions together, we need to identify whether this exhibits an arithmetic series or a geometric series so that we will be able to use the appropriate formula in finding for the sum. So let's try to see if this exhibits an arithmetic series. So again, we can tell if it is an arithmetic series if the common ratio among at least two consecutive terms is the same. So two consecutive terms, we take two terms backward, n plus 22 minus n plus 21, n cancels each other out. 22 minus 21 is 1. But that's not enough. We need to have at least a pair. So we need to have another pair of consecutive terms. That's n plus 21 and n plus 20. N cancels each other. 21 minus 20, that gives you 1. Now, two pairs of consecutive terms gives you the same difference, which is 1. That means we have a series that is arithmetic. Now, since we are getting the sum and the series is arithmetic, we will use now the formula for an arithmetic series, which is actually S sub n plus quantity n or equals n over 2 times quantity a sub 1 plus a sub n. Now, since we are looking for the sum, we are looking for this variable here, s sub n, because we are supposed to be looking for the sum. So, in order for us to be able to find for s sub n, we have to make sure that the variables n, a sub 1, and a sub n can all be found out of the given. So, we start with a sub 1. That's your first term. Your first term is there, n plus 20. So, we have this one. Your a sub n is your last term, which in this case we have it. That's n plus 100. So, we also have this one. The n here in this formula is the number of terms, which means how many expressions are there from n plus 20 up to n plus 100 that are being added in this series. Although you can say that there are only 4 terms in the series, but because it is a series, there are still other terms that are not written. And we don't know how many are they. So basically, using this formula, we don't have the n, so we cannot use this formula. Now, fortunately for us, we have the formula for finding the nth term of an arithmetic sequence, which is a sub n is equals to a sub 1 plus quantity n minus 1 times d. Now, the a sub n is your last term, which is n plus 100. We have it, so we substitute n plus 100. Your a sub 1 is your first term, which is n plus 20. We also have it. So this is plus here. That's n plus 20 plus quantity. N is the number of terms. That means, again, how many terms are added from n plus 20 up to quantity n plus 100. We don't know that. Copy it. Minus 1. D is the common difference, which we knew earlier to be 1. So you don't need to write 1. We just need to simplify this. This becomes n plus 100 equals n plus 20 plus n minus 1. You simplify this, n plus 100 equals 2n plus 19, because 20 minus 1 gives you 19. Now, if you simplify the entire expressions by isolating the variable n on one side and isolating the constants on the other side, that will give you an answer which is 81. Therefore, your n is 81. What does what does this mean? That means that all of these expressions from n plus 20 to n plus 100, there are 81 terms that are being added all together. So now, since you now have the value for your n, which is, again, remember, that is 81, we can now solve for the sum, which is, again, s sub n equals n over 2 times a sub 1 plus a sub n. Okay, s sub n is now equal to n is 81 over 2. A sub 1 is the first term, which is n plus 20, plus a sub n, which is your last term, which is n plus 100. Simplify that gives you s sub n. That's 81 over 2 times n plus n is 2n plus 20 plus 100 is 120. So you simplify that becomes s sub n is equals to 81 over 2. Then 2 is common in 120 and 2n, so we have to take out the 2 outside. We just remove that one. So that is 2 times n plus 60. Okay, so now we come up now with this one. If we simplify that further, the s sub n becomes equal to this one here. That becomes, you cancel that one out, 81 times n plus 60. So this answer now, this 81 times n plus 60, is now the sum of all the expressions in the given problem. Now, that means the number that is formed by the expressions by all the expressions combined in the given problem is 81 times n plus 60. Now, we are asked to solve for the value of n, which will make this number here, which happens to be this same number here, to be perfect square. Now notice that the number formed by the expression is consists of two factors, 81 and n plus 60. Now, in order for us to get a perfect square number, the two factors has to be a perfect square. So, one of the factors, which is 81, is already a perfect square, so we no longer have a problem on the 81. The only problem is the n plus 60, because we need to make sure that n plus 60 is a perfect square. Now, this is n plus 60. Notice that this has to be a perfect square, and this is 60. The constant part is 60, so we need to find a perfect square number within the 60s, or a perfect square number whose value is within the range of 60. So it should not be less than 60, so you cannot use 59. It should not be more than 6. Oh, it should not be more than 69, because you're only within you're only allowed to have numbers within the 60s. So you cannot use 59, you cannot use 70. So your only choice is from 61, or is from 60 to 69. But in these numbers from 60 to 69, there is only one perfect square number, and that is 64. That means the n plus 60 has to be 64. So in order to make n plus 60 become 64, you simply add 4 to 60. That means your n is 4. Meaning, the smallest number that can make this expression a perfect square is 4. So if you're going to try it, you can just have 81 times 64, then square root. You can have the square root of 81, which is 9, and you have the square root of 64, which is 8. That will actually give you 72. So notice that when we extracted the square root of this number, that gives us 72 whole number. That means that is a perfect square. So that's it for this video. I hope you're able to gain some knowledge. So please don't forget to like and subscribe our channel for you to be updated and notified for our next succeeding videos. So that's all for today. Thank you so much, and enjoy learning mathematics.